Today we're going to talk about generalizations. When you make a generalization, you're talking about a statement that applies to everything that is in a set or a group. A generalization can be true or it can be untrue. It can be correct or incorrect. Let's make a generalization about Miss Ritsky, Miss Parkhurst, and Mrs. Shoemaker. Now you could look at the three of us and know that we're teachers. And you could say, well, if Miss Ritsky, Miss Parkhurst, and Miss Shoemaker all have blonde hair, that means all teachers have blonde hair. It's a generalization based on what you know because that's a common attribute that we have. However, it's not a correct generalization. You throw Miss Shear in there and you have a brunette teacher. I could say all squares have sides that are equal lengths and they have 4 sides. That generalization would be true because every square I'd come across would have 4 equal sides. I could also make the generalization all triangles have 3 sides the exact same length. We know that this generalization is not true because you do have equilateral triangles, but there's also triangles that have 2 sides the same length and the other one's different. We call that scalene. Or you could have a triangle with sides all 3 different lengths, and we would call that an isosceles triangle. So these are examples of when generalizations can be true or not true. Let's look at this set. If I wanted to name each of these shapes, I could. I could say that this is a trapezoid. I could say that this is a rhombus. And I could say that this shape is a square. Or if I wanted to name all of them in one group, I would call them quadrilaterals because each shape has 4 sides. So in this set, they are all quadrilaterals. That's a generalization that I am making. Let's say my friend said that the generalization he was going to make is that all 4 sides are equal lengths on each shape. Would this be a true generalization or an untrue generalization? This would be an untrue generalization because I know a square has equal lengths and I know a rhombus has equal lengths, but look at this trapezoid. This parallel side is not equal to the other parallel side. So that generalization is not true. Let's look at this set. Let's see if we can make a generalization about these 3 shapes. First, I look at the sides and I see that this one has 4, this one has 3, and this one has 4. So I can't say that they're all quadrilaterals. I can say that they're all polygons. And I can't say that they all have sides the same length because this triangle doesn't and this shape doesn't either, this quadrilateral. But if I look, I see that this is a square with a right angle. This right triangle has a right angle. And if I look right here, this shape has a right angle. So I could also say that all 3 of these shapes have a right angle. And this would be a correct statement, a true generalization. Here's an example from one of my favorite games. It's called Set Game. And what you have to do is you have to make a generalization based on the set. The set either has to have all things in common or it has to have completely different things in common, which means it can either be all red or it has to be green, red, or purple. It can either be all diamonds or it has to be diamonds, circles, or squiggles. And it can either be all 1s, all 2s, or all 3s, or it has to be all 1, 2, and 3. So just looking at this set, I can make a generalization, and I could say that this one has 3 ovals and they are striped. And they're green. I could say this one has 3 ovals, they're striped, but they're red. And then I couldn't make any more. But I could say those had it in common. Set game is a really fun way to make generalizations and to see how things have things in common and how they are different. Try putting 3 things together and see if you can make a generalization about the 3 things you've put together. Practice at home. The better you get at observing and making generalizations, the better mathematician and scientist you can become.